Good morning. I am Veena, working as assistant professor in the Department of Electronics and Communication Engineering. And under the medium scale integration devices, we have learned all the adders, subtractors, right? So in this adders also one more topic that is nothing but serial and then parallel adders. Coming to the serial and parallel adders. So in this binary adders, we are having a classification under the binary adders. Those are nothing but a serial adder, parallel adder, and then carry look ahead adder. And one more adder is there, that is nothing but BCD adder. Okay. So in case of binary adder, so if you want to transmit the data serially, means bit by bit, so that we are using the concept called serial adder. So in case of parallel adder, entire bulk amount of data that can be transmitted to any block of the device, so that we need to use a adder known as parallel adder, right? So what is meant by binary adder? Binary adder is nothing but a combinational logic circuit which is used to perform the addition operation of 2-bit binary numbers of any length. Either it may be the 2-bit length or a 3-bit length or a 4-bit length. Based on depending on the number of bits, by adding the number of bits, the carry is generated, and you have to add the next carry to the remaining bits so that the length can be calculated. The binary adder is formed by with the help of a full adder circuit. We can form by using the binary adder. The full adders are connected in series, and the output carry of the first full adder, it will be treated as input carry of the next full adder. Coming to this serial adder. So in case of serial adder, a single full adder, it performs the addition of two 1-bit numbers and an input carry. Suppose if you want to add 10 or 11. So let us do the binary addition for this binary adder. So 0 plus 1, it resembles 1. So 1 plus 1 means 10. Sum is 0 and carry 1 is generated, right? So here 0 plus 1 is 1 and 1 is 2. What is a binary equivalent of 2 means 10 and 0 is sum and carry is 1 here, right? So we have to add the addition of two 1-bit numbers and an input carry, but a serial or parallel adder circuit is a digital circuit capable of finding an arithmetic sum of two binary numbers that is greater than 1 bit in length by operating on corresponding pairs of bit in serial or parallel. So let us take a full adder circuit considering with delay. So in case of full adder circuit, we are having the 3 inputs. For these 3 inputs, the delay input is connected to the input of one more full adder. So here the inputs are nothing but AN, BN and then CN minus 1. And the outputs are nothing but some output S0 and Cn. So these are the 2 output variables, and these are the 3 input variables for the single full adder in order to perform for the serial adder circuit. So in case of serial adder, what it requires means it requires only one full adder considering with delay circuit, and it operates in the synchronous with single clock pulse. So when we are having any clock pulse to this full adder circuit, it generates the output of the corresponding operation of sum as well as the carry, right? So the numbers that are added in order to apply to this input bit by bit, then have to be added. So here we are not giving directly the bits to the full adder. So for first bit, if you want to transmit AB as 10 or 11, so that what is the output that can be generated if the clock pulse is 0? What happens if the clock pulse is equal to 1? So if clock pulse is equal to 0 means no output is generated for the circuit in order to liberate the output of the corresponding waveform, right? So when the clock pulse is equal to 1, then only the circuit will be in the operating mode. So depending on the number of bits that can be generated as the input to the full adder, so the output bit can be calculated. So that is in a bit by bit fashion the serial adder addition can be takes place. The first 2 LSB bits, those are nothing but least significant bits, those are A0 and then Veena. Those are applied to the inputs of the adder during the first clock pulse. The third input will be 0 at this time. and means Cn minus 1 will be 0. And these bits are added in order to get the outputs. Those are nothing but the sum 0 as well as the carry bit is 0. The sum bit is taken out and it can be stored in the next half of the cycle. If you want to generate the clock pulse to the one more full adder, so the output pin can be liberated. So the carry bit is given to the input of the delay circuit. Means Cn minus 1 is equal to 0 for the first clock pulse, and again Cn minus 1 is equal to 1 during the next clock pulse of the first full adder circuit. So coming to this one, when the next clock pulse is given, then this carry bit means C0 that can be applied as third input to the first full adder, and remaining 2 bits of the binary number that can be added in order to generate A1 and then B1. Why? Because A0, B0 can be generated. For this time the carry C0 that can be applied as next clock pulse to this full adder circuit in order to generate the third bit for the full adder in order to operate the binary numbers of A1 and then B1. These 3 bits now are to be added in order to get the sum and then carry bit. And it can be seen that from the previous position it can be added to the current position bits. Those are can be added in order to get the A0 and then B0. This can be achieved by using the time delay circuit. And in case of serial adder, one full adder is adequate. Means in order to take this one, serial adder is highly economical. Why? Because in order to transmit the bits bit by bit, so the output it will take slow time in order to deliver the output. Then because of the delay, the outputs are calculated very slowly. That is the main reason in case of a serial adder circuit. So in order to overcome this problem, we are going for the parallel adder circuit. Means if you are cascading means if you are connecting the output of one stage to the input to the next stage, that is nothing but the cascading of n number of full adders that can be evaluated by in order to generate the sum and then carry out. Coming to the parallel adder, so due to this, in order to perform the addition between the 2 binary numbers of any length, so in case of parallel adder also, with the help of a full adder circuit, we need to calculate by using the parallel adder circuit. So here the full adders are connected in series, then the output of the first adder can be treated as input carry to the next full adder. So in order to get this n-bit parallel adder, we are connecting the full adders that are in the cascading mode in order to generate the sum and then carry. The carry and the first output that can be treated as a carry input to the second adder, right? Suppose let us take AB. These two are the augmented, and these are to be added in order to define by the subscript of the number. And here the subscripts are starting from right to left, and the lower order bit is defined by the subscript as 0, and the higher order bit for the subscript as 1. Let the C0, C1, C2 and then C3, these 3 are the carry inputs which are together connected together in order to form one chain. Those are by using a full adder circuit. So let us see the structure of parallel adder. So here S0, and for the first full adder 0, full adder 1, full adder 2 and full adder 3. So by using 4 full adders, how the next Cin can be generated, right? Suppose if you are taking the Cin as 0 for the first case, what is some S0 equation? Means A0 XOR with B0 XOR with Cin, right? So if you add A0 B0 as 0 or 1, right? So for this 0 exclusive, 1 exclusive 0, it resembles 1, right? So S0 becomes 1. Again, what about C0? C0 is nothing but AB plus BC plus Cin. AB means 0, BC means again 0, means C0 becomes 0, right? So this C0 is equal to 0, that can be act as input to the first full adder circuit, that is nothing but full adder 1. So if the second inputs are 1, 1, let us assume A1, B1 as 1, 1. So for this one, S0 will be 1 XOR with 1 XOR with 0, 1 XOR with 1 as 0, 0 XOR with 0 as 0. Again Cin means 1, 1 plus 0, 0 plus 1, it resembles 1. Again if C1 is equal to 1, that input acts as that C1 is equal to 1. This is act as input to the second full adder circuit, that is nothing but if Cin is equal to 1 for the second full adder circuit, suppose if you want to calculate A2, B2 as 1, 0, what will be your C2 value? And again what will be your S2 value? S2 is equal to A2 XOR with B2 XOR with Cin, right? So 1 XOR with 0 is 1. Again 1 XOR with 1 as a 0. S2 becomes 0. Now we want to calculate C2, the carry input for the second full adder circuit. 1 into 0 plus 1, 0 into 1 plus 1 into 1, it becomes 1. Right? Now C2 becomes 1. That can be acts as input to the third full adder circuit. Now the calibration can be takes place if both are 0. What happens for S3? And if C3 is equal to 1, what happens to the C3? Right? So 0 XOR with 0 XOR with 1, it becomes 1. Again 0 into 0, 0 into 1 and 1 into 0, it becomes 0. So this is the operation that can be takes place by using the parallel adder circuit when we want to calculate the sum and then carry equation for the full adder. In case of sum equation, A XOR B XOR C is the sum equation for the full adder. How the next carry outputs are generated, that can be acts as input to the next full adder circuit, right? So this is nothing but full adder, normal full adder circuit. Suppose if you want to perform the binary subtraction between the full subtractor circuit, what will be the case means, suppose if you want to subtract the numbers, what is the formula for finding the sum as well as the carry equation for the full subtractor circuit? So already we have learned in case of a medium scale integration devices under the adders, half adder, full subtractor and then half subtractor. So how the parallel binary subtractor is formed means, so you have to take all the full adder circuit by using the comprehend, means when you are having a C out value as 0, then you have to take the complement of that value, then the output can be generated for the next carry input of the full adder, means we have to take the NOT operation for the next output, so that can be generated. If it is 0, then you have to take the complement of that value. Then the sum and then carry equation will be different for the binary subtractors. So how the binary subtractor will be formed means, by taking the addition of the minuend of the 2's complement of the subtrahend, that is equal to what? The subtraction, right? Suppose if you want to take any value 0, 1, 0 or 0, 0, 1. Now you have to perform the 1's complement of this number. 1's complement means you have to replace zeros with 1's and 1's with zeros. And 1, 0, double 1, 0. So by taking the 2's complement of this number means by adding 1 with this 1's complement, it becomes the 2's complement of the number. Right? Means this is the 2's complement of the binary equivalent of this number. So we are getting the 2's complement as 10, 111 as a 2's complement as of the binary equivalent. So this process will be continued for the full adder circuit until the carry bit is added to the input of 2's complement of B in order to generate the last bit of the output, in order to take the carry bit as a 1. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.